Hi, I am Dhatri Patel. I am here to explain my project NIOSII Architecture. So, NIOSII is a 32-bit computer architecture which is developed by Altera. It is the second series of NIOSII architecture because the first series is of 16-bit. Moreover, it is a soft core RISC architecture. That means it doesn't require individual fabrication. It can implement in any FPGA-based embedded processor. So due to its unique features and flexibility, it is now world's most popular FPGA-based embedded processor. So let's talk about its architecture. As I said, it's a 32-bit RISC architecture. So it has 32-bit instructions, data path and address space. So it is a Harvard architecture, which means it has separate instruction memory and data memory. It consists of two parts, data path and control path. Apart from this, it has various functional units like register file, ALU, which form the foundation for the NIOSII instruction set. So depending upon these instructions, there are various addressing modes, depend upon type of operands. So they are immediate mode, register mode, displacement mode, register indirect mode and absolute mode. Now each instructions in NIOSII are 32-bit instructions and there are three types of instructions, I-type instruction, R-type instruction and J-type instruction. I-type instruction in which there are immediate operand. So 16-bit is of immediate operand. And in R-type instruction, there are three all operands are of registers. And in J-type instruction, it is used when there is a jump instruction or there is a branch instruction taken place. Now you can see that there are 6 bits of opcode fields in all instructions. So to execute all these instructions in program, it is necessary to see how these instructions will be executed in instruction flows. So now it's time to talk about pipelining. So there are 5 stages of pipeline. So now in NIOSII, all instruction will be executed in 5 stages like instruction fetch, instruction decode, instruction execute, memory access and write back. So instruction fetch. So as shown in the figure, there are all 5 stages are shown. So instruction fetch, first program counter will consist the address of current instruction and it will go to the instruction memory to see that at particular address which instruction is present, and this address or this instruction will store into instruction registers. Parallelly, there is an update in next PC, that is next program counter. So the address will be incremented by 4 from PC and it will go to next PC. Now this data will go to the next stage, that is instruction decode, where instruction will be decoded. So in this stage from IR, registers will be fetched and it will go to the register files corresponding to the registers used in instruction. So that register will go to next stage for further operation. Now in case of I-type instruction, if there is a 16-bit immediate, that will go to sign extend and to make 32-bit immediate. And apart from this, next PC will also go to next stage. Now the next stage is execute stage, in which particular operation will be performed in ALU and it will go to the ALU output. Now in case of store and load instruction, there is a data memory is used. In the data memory will provide a memory depend upon the load and store instruction. Now in the case of branch instruction, there is also stage of condition or the branch will be compared and it will go back to the PC to jump to the target address. Now finally the result will be stored through write back stage and it will go back to the register file. So you can see that this is all about 5-stage pipeline, and you can see that there are main components are program counter, instruction memory, registers, data memory. So while implementing Verilog code, it is necessary to design all these stages. So I have implemented Verilog code, but now this is the benchmark program of dot product, where you can see that vector A and vector B will go to register R2 and register R3. The result will be stored in register R5. So this program is corresponding to NIOSII. So while implementing register Verilog code and after simulating, I can get the waveform like this. So you can see that there is a 5-stage clearly shown. This is the waveform of dot product program. So 5 stages clearly shown here, but where there is a data dependency in instruction, that means there is a data hazard. So it is necessary to add one stall here. So data hazard is removed here. Now finally this is intermediate operations are performed, and finally result will be stored at register 5, value is 38 hex. So this is all about dot product, and I have also implemented factorial, but it shows some error in waveform. So finally conclusion. So it shows that dot product is successfully implemented and data hazard is also removed. So overall experience is good. I can learn many things. Thank you.
Auto कर